Hi, this is Purnima Mahanegam, and you're watching video lecture series on power system protection switchgears. In this video lecture series, today we are going to see about the methods of grounding. Come, let's continue. Here, starting about methods of grounding. First, we are going to discuss about neutral grounding. What is neutral grounding here? It is so connecting the neutral point to the earth. We are connecting to the neutral point to the earth as direct to either directly as some circuit elements. So example circuit elements like resistance, reactance, Peterson's coils, etc., which is called as neutral grounding. So the neutral grounding provides protection to the equipments. Our main aim is to protect the equipments. And during the earth fault and current path is completely neutral. So for that, neutral grounding is very, very, very important. Uh, Here coming to the advantages of neutral grounding. So voltage of the healthy phase do not exceed the line to the ground voltage. They remains nearly constant. The high voltage due to the arc groundings are eliminated. So when arc grounding, what happens is suddenly the voltage get increases, whatever maybe happens. So that is eliminated. So life of the insulation will be very long because of this neutral grounding, and the over voltage is reduced. It provided greater safety to the personnel and equipment. It provides improved service reliability, and operating and maintenance expenditures are reduced. So main thing is operation cost and maintenance cost is also reduced because of this neutral grounding. Hmm. Here comes with the methods of neutral grounding. We have solid and effective grounding methods and resistance methods, reactance methods, and Peterson coil methods and voltage transform methods. So these are the methods we are going to discuss. Coming to the solid grounding methods, what happens? It is we have a three-phase. This is the time we have to protect it. So this star connector, which is grounded directly without any external components. If any fault occurs in the three-phase, examples we can say that the fault occurs in the phase B. What happens is directly connected with the ground, and what happens is directly grounded. So what happens here? It is this is the fault current. This is what happens. This fault current goes and grounded. It goes to the neutral. What happens? It is the next is solid and effective grounded. It won't affect the other two phases. Here coming to the what happens here, the neutral and ground. What happens? We haven't we added an resistance here. So what happens? It controls the fault current. It controls the flow of fault current. We know that the resistance controls the flow of current. Here, what it is doing, it is controlling the flow of fault current. Now we can see here it is the same phase B as a fault occurs. So which does not, which won't, which is not affected for other two phases. That is a main important thing. Here, what happened is a fault current, and this fault current goes when it crosses to the with the resistance. What happens? The current as fault current can be controlled. Here, the neutral of the three-phase system and three-phase generator, three-phase transformer is connected to the earth. So the resistor is called as resistance grounding. Here we can see. Here we can see capacitors also. Here's the reactance grounding. Here we are connecting the same thing, a reactance. What happens? It is coming to here. It is. Here reactance grounding the same fault. A fault occurs, it faults go through the reactance. This is also known as the arc suspension coil. That's also called as an arc suspension coil. What is an advantage of Peterson coil? It is the Peterson coil has the following advantage. The Peterson is completely effective in preventing any damage of an arc grounding. It is main thing of using this arc suspension coil is to preventing the damages. The Peterson coil has advantage of underground neutral systems. And disadvantage, the Peterson coil ground has the following disadvantage. Due to the varying operating condition, the capacitor of the network changes from time to time. Therefore, the inductance of the Peterson coil records readjusts. The capacitance changes to time to time, but the inductance of the coil records readjustment. So the line should be transposed. Here and finally, we are coming with the methods of grounding here. We have seen so many methods of grounding. First is the methods of grounding is resistance grounding. So the neutral grounding through the resistance and limits the fault current, reduce the damages. So India power system is a low transmission, high this transmission is. So then is reactance grounding, the neutral grounding through the reactor and limit fault current and less costly for high voltage, less costly for high voltage and rarely used today, rarely used today. Here the reactance grounding and resonance grounding, here it is, that is also known as Peterson coil grounding. It's a reactor tuned to system capacitance and minimize air fault current and which is suspends the ground output. So the main thing of Peterson coil is the ground output which suppress the ground output. This is what is an overhead distribution line. And coming to the underground system, the neutral not connected to the earth, it's very small fault current, line voltage rises during fault. So the early distributions areas. Here come the neutral directly connected to the earth, solid grounding and fast fault current clearance. Here we can the is directly connected to the ground. So fault clearance will be very fast and simple and economic and high fault current. So here the cure is the low voltage distribution transfer. Choosing resistance value is a protecting design art, not in a guesswork. So, fun fact, underground system hide faults like studies, hiding attendance, shortages, etc. So, underground fault is, what about is it the small fault is, what happened is a small fault is can be, mm, what to say, it is hiding. And now coming to the comparison selections, what happens? Solid grounding was for high fault current, and resistance grounding is a control current, and resonant grounding is a arc suspension. Depending on the voltage level and safety, we can select the type of solid ground for high fault current or solid grounding is better. For controlling the current, fault current, resistance grounding is best, and for arc suspension, resonance grounding is best. So depending upon the voltage level and for safety, we can choose any type of ground. With this, today we are ending up this series and we'll meet in the next. Thank you so much.